Good morning, students. Today we are going to start with the chemical properties of carbon compounds. In the previous standard, we learned that carbon in the form of various allotropes on ignition in presence of oxygen undergoes combustion to emit heat and light and forms carbon dioxide. Similarly, hydrocarbons and most of the carbon compounds undergoes combustion in presence of oxygen to emit heat and light and forms carbon dioxide and water as the common product. Let us see the reaction, some reactions where the carbon compounds undergoes the combustion and forms carbon dioxide and water as a common products, and similarly they emit heat and light. So you can see methane as well as the ethanol, when they undergoes combustion, means they slowly combines with the oxygen and forms the, we can say, carbon dioxide and water as a common product, as well as heat and light gets emitted. Then let us see the second property, chemical property of the carbon compounds, that is oxidation. The carbon compound is completely oxidized during combustion. Chemical compounds can also be used as a source of oxygen. Substances that give oxygen to other substances are called oxidant or oxidizing agent. It was learned in the third chapter of our science 1, that is about the chemical reaction. We have learned that when the substance give oxygen to other substance, then that substance is called as a oxidant or oxidizing agent. The potassium chlorate, potassium permanganate, these are the, we can say, substances. They give oxygen to the organic compounds. That oxygen is the nascent oxygen, and that nascent oxygen oxidizes the organic compounds. So similar here, ethanol is there. Ethanol, it after oxidation, in presence of alkaline potassium permanganate, it gives the ethanoic acid. It is also called as acetic acid. So ethanol, when combines with the, we can say that the it undergoes the oxidation reaction, and this oxygen is a nascent oxygen. It is given by the, we can say, this alkaline KMNO4. So we get the acetic acid, or also called as a ethanoic acid. Let us see the third reaction, that is called substitution reaction. Substitution reaction, the reaction in which an atom or group of atom is replaced by another atom or group of atom, then that reactions are called substitution reaction. In organic compounds, we can say, or in the hydrocarbons, the hydrogen is replaced by the, we can say, another atom or group of atom, then that reactions are called as a substitution reactions. Saturated hydrocarbons in presence of sunlight reacts rapidly with chlorine. In this reaction, chlorine atom replace one by one all the hydrogen atoms in the saturated hydrocarbon. So here you can see how the hydrogen is replaced by the chlorine. First, the methane, it has four hydrogen one. First hydrogen is replaced by chlorine and forms the methyl chloride, CH3Cl. This CH3Cl again combines with the second molecule of chlorine and forms methylene dichloride, that is CH2Cl2. Again, this CH2Cl2 methylene dichloride reacts with the third molecule of chlorine and forms chloroform, that is the CHCl3. This chloroform again reacts with the fourth molecule of, we can say, chlorine and forms carbon tetrachloride. So in this way, all the four hydrogens of the methane are replaced by chlorine and form the respective products. So here this reaction is called as a substitution reaction. Means here the chlorine gets substituted in place of the hydrogen. Let us see some common important compounds. The first compound, that is the ethanol. Ethanol at room temperature, it is a colorless liquid and its boiling point is 78 degrees Celsius. Generally, ethanol is called alcohol or spirit. Ethanol is soluble in water in all proportion. When aqueous solution of ethanol is tested with a litmus paper, it is found to be neutral. Means it is neither acidic nor basic. Let us see the chemical properties of ethanol. Ethanol reacts with the sodium and forms, we can say, sodium alkoxide with the liberation of hydrogen gas. In the reaction of ethanol with sodium metal, hydrogen gas and sodium ethoxide are formed as a product. You can see in the reaction, the ethanol reacts with the sodium and forms sodium ethoxide with the liberation of hydrogen gas. Then second property about the, we can say, the dehydration of alcohol. This alcohol is there, this undergoes the, we can say, dehydration reaction. Dehydration is nothing but the, we can say, the removal of water. So the water from the alcohol is removed, then that reaction is called dehydration. D means removal, hydration means water. Water is removed from the, we can say, alcohol, so it is called dehydration of alcohol. When ethanol is heated at the temperature of 170 degrees Celsius with excess amount of concentrated sulfuric acid, one molecule of water is removed from its molecule and form ethene as an unsaturated compound. So you can see the reaction. Ethanol in presence of concentrated H2SO4 at the temperature of 170 degrees Celsius, it forms the compound CH2 double bond CH2. So this CH2 double bond CH2, it is called ethene, which is an unsaturated hydrocarbon. Here the concentrated H2SO4 is act as dehydrating agent. Now let us see the next compound, that is the ethanoic acid. Its common name is acetic acid. So ethanoic acid is a colorless liquid with boiling point 118 degrees Celsius. It is commonly known as acetic acid. Its aqueous solution is acidic, but if we take the, it is all in water, if you take that solution, it is called the aqueous solution. The aqueous solution of, we can say, this ethanoic acid is acidic. It means it changes blue litmus paper red. The vinegar, which is used as preservative in pickles, is a 5 to 8% of aqueous solution of acetic acid. The melting point of pure ethanoic acid is 17 degrees Celsius, 17. So it melts at, we can say, 17 degrees Celsius. Therefore, during winter in cold countries, ethanoic acid freezes at room temperature itself and look like ice. Therefore, it is named as glacial acetic acid. So after studying this, we can say this, the importance, or we can say the information about the ethanoic acid. Let us see the chemical properties of the ethanoic acid. Ethanoic acid, it contains the carboxylic acid as a functional group. The chemical reaction of ethanoic acid are mainly due to functional group. Let us see first reaction, the reaction of the ethanoic acid with the base. Ethanoic acid gives neutralization reaction with a strong base, that is sodium hydroxide, to form salt and water. You can see the reaction, the where the ethanoic acid reacts with the sodium hydroxide and form the sodium acetate, and that is the plus, we can say that we get the water. Here salt and water is formed, so it is called as a neutralization reaction. So this is here CH3COONA, it is called as a sodium ethanoate. Its common name is sodium acetate. Means here IUPAC name of the, we can say, this sodium acetate is sodium ethanoate. So about studying this, we can say that this sodium acetate one. Now let us see the reaction of the ethanoic acid with carbonate and bicarbonate. Ethanoic acid reacts with the, we can say, the sodium carbonate and forms water, sodium acetate, water, and carbon dioxide gas. Similarly, the ethanoic acid reacts with the, we can say, the sodium bicarbonate. It also forms the sodium acetate, water, and carbon dioxide gas. In both the reactions, we can find that the carbon dioxide and water is formed, and similar products are formed after reacting with the, we can say, base. Means when acetic acid reacts with the, here the, we can say, the base one, then it forms the salt and water. These are nothing but the, we can say that the some reactions of the ethanoic acid. So let us see the one more reaction, that is called the esterification reaction. Substances having ester as a functional group are formed by the reaction between this carboxylic acid, that is similarly we can say ethanoic acid, and alcohol. So this reaction is there where we can say that the acid reacts with the alcohol and forms the, we can say, ester and water. So you can see the reaction, that is ethanoic acid reacts with the ethanol and forms the ethyl ethanoate. It is called ethyl ethanoate, or we can say that the ethyl acetate also, and plus water. So esters are there, they are, we can say that the having the, so esters are there, they have the sweet odor. Majority of fruits owe their color to a particular ester present in them. Means fruits are there, they gets the, we can say, odor because of the ester present in them. Esters are used for making fragrances and flavoring agents. When an ester is react with the alkali sodium hydroxide, the corresponding alcohol and carboxylic acid are obtained back. Means in the previous, in the reaction where the, we can say that the ethanoic acid reacts with the alcohol, it is presence, in presence of acid it forms the, we can say, ethyl ethanoate and water. But same the, we can say that the, when ethyl ethanoate is reacts with the, we can say, uh, alkali like sodium hydroxide, we get the backward reaction, that is the, we get the acetic acid and ethanol back. So this reaction is there where we can say that the, this ester reacts with the sodium hydroxide and form the sodium carboxylate and alcohol. This reaction is there, is also called as a, we can say, the saponification reaction. So this reaction is used for the preparation of soap from fats. So after studying this all the types of the reaction, now students, you can see the textbook. In the textbook question number, we can say that the 6 is, we can say, the is for the homework one. There you have to identify the type of the reaction of the carbon compounds. Just you have to identify whether it is combustion reaction or oxidation reaction or substitution reaction or esterification reaction, whatever it may be. You just see, go through the each reaction and find the type of the reactions of carbon compounds. Okay, take care and thank you.